One day, Miss Nichols was dancing on her home to Olivia Newton-John. Good job dancing, Miss Nichols. Suddenly, she saw Jordan and Gabee approaching her residence. She despised people on her property and demanded they leave the premises. Jordan and Gabee didn't know what to do, for all they wanted was homework help. Suddenly, she chucks an orange at Gabee. Golly gee, an elastic collision has occurred. This is where two objects collide and bounce off each other. Now hold on a second. This situation can go either two ways. A. Gabee takes the orange and walks away unharmed. Or B. Gabee gets a concussion and Miss Nichols loses her job. Ding! We can predict this by calculating the velocity of the said thrown orange. Let's start with the known variables. We have the height of which the object is thrown, and we also have the acceleration. Gabee is 5 feet 5 inches, but let's just say 1.683 meters. Now we need to find a formula.
Is it this one? No! How about this one?
I don't think that's the one.
Could it be this one?
Yeah! First of all, a little pre-thinking. Is the height really 45 meters? Because it is hitting Gabee's head and not the floor, you need to subtract her height from the distance it's falling from the ground. Then you just plug in your known variables in the equation. First, you start out with the formula we've chosen earlier. Then you plug in the known variables. Since you know all of the variables other than VF squared, you can multiply them all together to simplify. Because you're finding VF instead of VF squared, you only have VF squared right now, so you have to square root the whole thing in order to find VF, which is final velocity. And there's your answer, 29.13 meters per second. That's pretty darn fast, but because Gabee uses Aquanet, she was unharmed. Now Miss Nichols won't suffer from a lawsuit. So Miss Nichols got to keep her job, and Gabee walked away unharmed. Today, all is right in the world of physics. Now everyone dance!